In this video, I'm going to review how to simplify radical expressions. Make sure you take this chart out. This chart was provided to you about a week and a half ago. Let's get started. So here's our very first example. I want negative 8x to the negative 12, all raised to the 4/3. This is example number 1. How do we go about simplifying this? Let me zoom in a little bit for those in back. Well, I need to apply this, think of it as distributing, to both terms that are inside. So I'm actually going to rewrite this as negative 8 to the 4/3 and 12 raised to the negative 12, x raised to the negative 12 to the 4/3. All right, so let's start out front with this value. When we break this down, yes, we could plug it into our calculator, we can get an answer, but I want you to achieve this answer without using a calculator. You can use this chart as a guide. When we do this, the very first thing we're going to do is we're first going to apply that bottom number, which is a 3, and then I'll go back and I'll apply the 4 later on. So what does this mean? Some of you may want to circle it like this. It means go into the third column and let's locate negative 8. Third column, okay, here's positive 8. That means 2 times 2 times 2 3 times is positive 8. But I want a negative 8. I recognize that negative 2 times itself 3 times, an odd number of times, will produce a negative 8. So this portion is equivalent to negative 2. Now I need to take negative 2 times itself 4 times. Well, I have an even number of negatives because there's 4 negatives. Now, what's 2 to the 4th without using a calculator? Here's 2 to the 1st, to the 2nd, to the 3rd, to the 4th. This portion is positive 16. When you have an exponent raised to a higher exponent, we're going to multiply. So I'm going to come off the side. Negative 12 over 1 times 4 over 3. There's a couple different ways we can do this. The first thing is recognize is we only have 1 negative. So that's an odd number of negatives. That means my final answer will be negative. Second is I'm going to choose to reduce this. 3 divides into itself once. 3 divides into 12 4 times. 4 times 4 is 16. 1 times 1 is 1. So right now I have 16x to the negative 16. And although I have not made any mathematical mistakes, this cannot be my final answer. I have 2 different parts that make up this term. The 16 is happy because it has a positive 1 as the exponent. The x is not. When it goes down to the bottom, it is now happy. Oh, how do we do this problem? Well, I'm going to draw arrows here as I'm distributing it. So I have negative 64 raised to the 4/3. I have an x to the negative 6 raised to the 4/3 as well. Now, this means go into the third column and locate, is there a value I can take times itself 3 times and get 64? There sure is. It is 4. 4 times 4 times 4 is 64, but I want a negative 64. And because it's an odd number, 3, I know negative times negative times negative is, in fact, a negative, in this case, a negative 64. So this portion results in a negative 4. Now we need to see what is negative 4 times itself 4 times. So I find 4, and this is 4 to the 1st, 2nd, 3rd, and 4th. So 256. I have an even number of negatives because those that are visual learners could expand this if you wanted. We have 4 negatives, and an even number, 4, of negatives results in a positive answer. Now let's look at the next portion. So I'm going to bring this off to the side. I have negative 6, which we can put a 1 on the bottom, times 4/3. Now, I could multiply straight across and get 24 over 3 if I wanted to, and then reduce it down to a negative 8. A common mistake I see students make is they look at this and they assume, oh, it's not happy. Well, what's not happy? Because there's 2 different parts that make up this entire term. The 256 is happy. We'll keep it where it is. The x will go down to the bottom, and this problem is. Let's take a look at a second type of problem. We're going to start off very easy with this particular problem. So I want to reduce this. It is in radical expression. So I ask myself, okay, 5. I go into category 5 or column 5 and locate, is 32 there? In fact, 32 is there. So 2 times itself 5 times gives us 32. So I'm able to take this out of the radical and reduce it down to a 2. Now I'm going to do this the long way that I explained before. This is the long way of doing this. I could rewrite this a to the 10th in terms of groups of 5 as a5 and a5 because 5 and 5 is 10. I could rewrite 25 as b5, 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 and b5. You get the idea. Is it required? Not at all. So how many full groups of a to the 5th do I have? I have 2 full groups. So I'm able to take it out of the radical and reduce it as a squared. Likewise, how many full groups of b to the 5th do I have? I have exactly 5. How many full groups of c? Well, I haven't taken time to do it yet, but here's how we can do it in our head. How many groups of 5 can evenly fit into 50? 10. This is fully simplified. Let's take a look at the next one. Begin working on this next example. How would I begin on this? I'm going to look into column 3 and I'm going to locate 125. Locating 125 in column 3. And what does this look like? It looks like 5 times itself 3 times gives us 125. But notice that it's a negative sign. So this is a negative 5 because negative 5 times negative 5 times negative 5 is in fact negative 125. It's an odd number of negatives. You could not have an even nth root and still end up with a negative. You could not have an even nth root and end up with a negative. All right, now how can we do this in our head without having to expand everything on paper? How many groups of 3 can fit into 7 without going over? 2 groups, nice job. So 2 groups can fit in. 2 times 3 is 6, but I need 1 more. There's a remainder of 1 inside. How many groups can fit into 11 without going over? So you're going to count by multiples of 3. 3, 6, 9. I can fit 3 groups of B. 3 times 3 is 9, but I need to get to 11. That means I have 2 remaining. Lastly, how many groups of 3 can fit into 15? We have an even 5. This next problem is going to be timed. It'll be our last problem just like this. Actually, let's do 2. Let's do this one first. Without talking, let's see if you can complete this problem in under 20 seconds. Could you prove that your answer works? Or maybe it doesn't work. Watch this. Okay, I'm going to go into column 4 and I'm going to locate a 16. I saw a lot of you doing that. You come off to the side and you say, okay, 2, but I want it to be negative. So you're going to put negative 2 4 times. So 2 times 2 times 2 times 2 is in fact 16, but I want a negative, so I have to make it negative 2. But I have an even number of negatives. What does an even number of negatives produce? Always a positive, not a negative. This is no real solution. Let's move on to the next one. It's our last one from this type. Thank you for your patience. Here we go. Begin. Can I fully simplify this radical? Notice I have a negative number inside, but that's okay because it is an odd nth root. So I go to 243. I'm going to go across to the left and I locate 3. I believe negative 3 times itself 5 times is in fact negative 243. How many groups of 5 can I pull out of 3? You can't even pull out one group. You cannot pull it in one entire group, so the remainder stays inside. How many groups of 5 can you pull out of 8? One group. 1 times 5 is 5, but there's a remainder of 3. How many groups of 5 can you pull out of 21? 4 full groups. 5 times 4 is 20. There is a remainder of 1. We're going to go on. How can we simplify this? So I don't see a radical here, but I do have a rational. I have a rational exponent. That means a fraction in the exponent position. Let's go to column number 2 and let's locate 27 and 3. Is 27 in this column? No. Is 3 in this column? It's not. But because I can see that I have the exact same exponent, we're going to rewrite this. Please do the following with me. 27 over 3. So 27 divided by 3. And they both, meant to make that bigger. They both have a 1/2. That's why I can do this. If they didn't have the exact same exponent, I could not. Don't forget about the -4. So now it's like I've ordered these. I've decided what order I am going to divide these in. 27 divided by 3 is 9. 9 to the 1/2, and then raised to the -4. Okay, let's find it. 9 to the 1/2. That means go into column number 2, locate a 9, go off to the side, and it is a 3. So this portion is a 3. Now I'm going to take 3 to the -4. Well, let's just first decide what is 3 to the 4th. Then we'll talk about the negative sign later. 3 to the 4th, here's to the 1st, 2nd, 3rd, 4th. So it is 81. This is 81, but when it's a negative exponent, where does it need to go? To the bottom. So 1 over 81. This would be my final simplified answer. I'd like you to do the next one. 192 over 3, both raised to the 1/2, and then raised to the -3. I'm going to give you 45 seconds once I pull this down so everybody can see it. Bless you. Please begin. So I'm looking at my chart, and although 192, I don't even know if it's here, 192 is past this point, I can see 3 is not on the chart. And so remember, we're trying to do this without a calculator. So I'm going to take right now and rewrite this. 192 over 3, and they both have the same exponent. That's why I can do this. Okay, 192 over 3, I'm going to come off to the side. 3 can go into 19 6 times without going over. 6 times 3 is 18. Subtract and bring down the next number. 3 can go into 12 4 times. Okay, this number reduces to 64. So 64 to the 1/2. I'm going to go back into column number 2. I'm going to locate 64. It is right here. This is column number 2. I go off to the side and I achieve an answer of 8. This does not mean 8 times 3. It's 8 to the 3rd. So let's locate 8. 8 to the 1st, 8 to the 2nd, 8 to the 3rd. Why, if I put 5, 12, why is this not accurately the simplified answer? What have I forgotten about? Because it's negative, I have to do 1 over that number. Okay, we're going to go back to what do radicals look like. But before I do that, I want to see if you can take what we just went over and apply it to this particular problem. Let's keep it very simple. Here we go. I want 30 to the 6th power divided by 10 to the 6th power raised to the 2 over 6. What can we do here without using a calculator? These are pretty large numbers. 30 times itself 6 times, 10 times itself 6 times, then raising it to a 2, 6. This looks confusing. Do I have the exact same exponent? Yes. So let's break this down. 30 divided by 10, they have the exact same exponent, and then we'll raise it to the 2/6. Well, 30 divided by 10 is 3. Okay, that's simple. And before I go ahead and go, okay, I can go on the paper. Let's figure out what 3 to the 6th is. Before I do this, 3 to the 1st, 2nd, 3rd, 4th, 5th, 6th. Before I change this into a 729, here's what I recognize. When you have an exponent raised to a higher exponent, you always multiply. So I'm going to come off to the side. 6 over 1 times 2 over 6. 12 over 6. 12 over 6. Well, what is 12 over 6? 12 over 6 is simply 2. 3 to the 2nd power is 9. This entire thing is equivalent to 9. You are going to have a timed problem just like this. As soon as I get done writing the next problem, I'm going to count in my head and see if you can finish it in 30 seconds. Here's your next problem. Simplify this radical expression. 27 to the 5th over 3 to the 5th, all raised to the negative 2/5. I'm going to bring it down so everybody can see it. I'll give you a chance to write it down, and then I'll begin counting. Your 30 seconds begins right. What we do here? We have the exact same exponent. So 27 over 3 to the 5th. We can only do this when we have the same exponent and we're multiplying or dividing. Now, 27 divided by 3 is 9. And before I try to figure out what is 9 to the 5th, I recognize I have an exponent raised to a higher exponent. So I'm going to take these off to the side, 5, which is the same as 5 over 1 times negative 2/5. I end up with negative 10 over 5. Well, negative 10 over 5 reduces to a negative 2. This answer, like I see a lot of students believe, it's negative 18. That's not true. First of all, just what is 9 squared? 9 squared would be 81. But this 81 isn't happy because it had a negative sign in the exponent. It is 1. We have a radical expression in this particular example. And our goal, like every other example today, is going to be to simplify this. Notice that the nth root is exactly the same. It's a hidden 2. And we can only do this when they are being multiplied or divided and they have that same nth root. So I'm going to put these together. I'm going to make a large radical. Again, they have the exact same. And I'm going to see what I can do here. Let's see what kind of mental math I can do. 32 divided by 2, because I'm dividing here, right? So with the large numbers, the coefficients we divide. What is 32 divided by 2? 16. Now, what do we do with these exponents? We are going to, when we are dividing, we're going to subtract top minus bottom. So 10 minus 5 is 5. 15 minus 7 is 8. Now this should look like a problem that you've done earlier today. So I'm going to go into column number 2 and I'm going to locate a 16, bless you. I go off to the side and I end up with a 4. This gives me an answer of 4. How many groups of 2 can I pull out of 5? Anyone? 2. But is there a remainder? What is the remainder? 1. How many groups of 2 can I pull out of 8? 4, and there is no remainder. This is my simplified answer. Okay, let's have you try this one on your own. Here we go. On top is going to be the square root of 8, x to the 6th, y to the 24th. And on the bottom is going to be the square root of 2, x squared, y to the 10th. Let's see if you can simplify this radical expression in under 30. Let's go through this. So we have the same nth root and we are dividing. We can only do this when we are multiplying or dividing. All right, so we have the same nth root. 8 divided by 2 is 4. What do I do with these exponents? When we divide, we subtract, we have the same base. 6 subtract 2 is 4, and 24 minus 10 is 14. I go on to column number 2. I locate the 4. I go straight across, and it is 2. Okay, how many groups of 2 can I take out of 4? An even 2. How many groups of 2 can I take out of 14? An even 7. I don't need to put the radical. This is my final simplified answer. Yes, go ahead. This 2 right here? Okay, this 2 right here. When you don't see an nth root, it's a hidden 2. So this is the next type of problem. We have one more type after this. So what we need to do is we need to take this radical expression and we need to share it with the numerator and the denominator. So we're going to do that first with the numerator and second with the denominator. All right, now we didn't do anything mathematically wrong, but here we go. You ready? But if we ever end up by leaving our final answer with a radical on the bottom, we're in trouble. It's not proper. So let's look into column number 4 and let's find the 8. Okay, column 4, because that's the nth root. Let's find 8. Is 8 in here? 8 is between 1 and 16. So grab your calculator at this time. We're always working down. Please take 16 and divide it by 8. If we get a nice whole number, we just hit the jackpot. If not, we go on to 81 to 256 until it works. Does 16 work? 16 divided by 8 is in fact 2. Whatever we do to the top, we must also do to the bottom to ensure this original expression keeps the same value. So now I have the 4th root of 6 on top and the 4th root of 16 of 16 on the bottom. All right, let's find the 4th root of 16. 4th root of 16 is right here. I go straight across and I have an answer of 2. That means my bottom number is 2 and the top is the 4th root of 6. That's as far as I'm going to go. A lot of students make a mistake, and they're very eager to continue to reduce, and they go 6 divided by 2 is 3, and that's my final answer. Not true. These are not like terms if you want to think of them that way. This is my final answer. Okay, ready? Here's your problem. I'm going to time you. It's very similar to the last one. 30 seconds. Let's see if you can come up with a simplified answer for this expression. Is the 2 on the column that's in the fourth column? It is not, but it's located between 1 and 16 in the fourth column. So I'm going to take 16 divided by 2, and I get a nice whole number of 8. Bless you. So I need to extend this times 8. So I have the fourth root of 8 on top, the fourth root of 16 on the bottom. And when I look at my chart, I can see the fourth root of 16 is, in fact, 2. So I have fourth root of 8 over 2. These cannot be reduced further or joined together. This is my final answer. Now, so far, give me, if not, speed's not a factor, give me a 1 through 5 and how you're feeling about this review, 1 through 5. Okay, you are allowed to use your notes today as you go on to our next activity, but we have one type of problem left, and this is it. So I need to take the negative 2/3 and I need to apply it to the 2 and to the 16. But before I do that, I'm already thinking ahead. So I'm thinking, okay, third column, right? Third column. I'm like, oh, no, I'm in trouble. In the third column, there is no 2. In the third column, there is no 16. But can 2 and 16 be reduced? Yeah. Here's the mistake students make. Watch. Why does this not translate into this? Anybody hands up high if you know what it is? Yeah, 16 divided by 2 is 8. But divided by 2 is 1. Divided by 2 is 8. So this is 1/8, not just simply 8. Okay, you ready? Here's our next thing. We're going to apply this 3 on the bottom. Okay. We're going to apply the 3 on the bottom to both of these. So I'm going to apply it to the 1, and I'm going to apply it to the 8. So technically, here's what we're doing. We're applying 1/3 to the 1 and 1/3 to the 8. And then I'll come back with that negative 2. So how do we do this? Here we go. Go to the third column and locate is 1 there. It is. That means 1 times 1 times 1 3 times is 1. Let's go to the third column and see is 8 there. It is. That means 2 times 2 times 2 times 2 3 times is 8. Okay, I've done that. Perfect. I've taken care of that. Now I have to apply this negative 2. So it needs to be generous, and it needs to be applied both to the top and to the bottom. Is the 1 on top happy? No. So it goes to the bottom, and now it's happy. The 2 on the bottom is not happy, so it goes to the top, and now it's happy. 2 times 2 is 4. 1 times 1 is 1, and this simplifies simply to 4.